Hello everybody and welcome to another video on my channel. This is actually the first video we are doing in a very long time. Sorry for the wait. I actually recently got a new iPad, the iPad Pro M5, which I'm recording this on right now. And this will be my new workstation for practically everything, including editing. So please tell me if you notice any quality changes, because I hope you do, as my old iPad was around like 7 years old, so it was getting very old and it was not working as well. So I hope that I can give you better quality videos with this new iPad. But besides that, I think everything will be going back to normal. And for my math videos on my other channel, of course at the end of the video there will be a link to that channel. I will also be changing to using this app for drawing and for explaining my math concepts. Let's move on to the video. Today's video is actually still about math, but it's a math review for physics or mechanics, which is a branch of physics. This is going to be reviewing a lot of the math we're going to need for onwards, because we only covered most of the basics of kinematics, as there's not really much you can do with kinematics after you did what I did. Of course, we can expand it into 2 dimensions, but we'll cover that more in mechanics. And also, we have to make sure that we know the math behind that, specifically vectors. So I'm going to be covering vectors today and a little bit of trig review. So let's move on to the main topic of this video, which is an intro to vectors. So vectors are something with both a magnitude and a direction. So if we draw a coordinate plane like this over here, and then what we can do is, let's just say we draw a point on this plane. This point will be a scalar because it has a magnitude, or basically like where is it, but it doesn't really have a direction. On the other hand, if we have a vector like this, an arrow pointing here, this would be a vector since it has a magnitude, which is 1 unit up and 3 units to the right. So 1 squared plus 3 squared square root is equal to the square root of 10. We have that ready over here, but this is not the full story, because I said we already have the direction, which we will figure out, and I will show you how to figure out. With understanding vectors, let's learn a few basic operations. Those will be going from x, I hat, y format, or I hat, j hat format, basically representing in terms of like x, y, or unit vectors, and also in 3 dimensions, I'll show you that, into the magnitude of the vector. If we have a vector A, it's often represented by this, and then the direction, or theta, and vice versa, of course, the opposite way around. We will learn how to add vectors, and then we'll figure out the resultant vectors, also subtract vectors. Then we will also learn how to multiply a vector by a scalar. And as a final thing after that is to break up a vector into its different components. And then after I show you how to do all of that, we will combine them all into one slightly bigger problem. It will not take very long, but it will still be very beneficial for us to solve it. And then, assuming you already know trig and algebra, if you don't, you be sure to watch my videos on my math channel where I cover those concepts. So what you can do is, after you watch those, you should be ready, and after you watch this, of course, make sure to watch to the end, you will be ready for tackling the rest of mechanics, physics, and most other advanced concepts as a whole. So let's begin. The first thing is, if we have this 2D plane over here, I hat and j hat represent the coordinates. So I hat and j hat are actually the unit vectors, where I hat is the one to the right, or the positive x vector, but then j hat is 1 unit in the y direction straight upwards. I hat and j hat both have a magnitude of 1, but they are 90 degrees from each other because of the fact that they're moving. Sorry, of the fact that they're in different axes. Now, magnitude and direction. Magnitude is if we draw a vector. Let's not use the same one. Let's use a different one. If we have a vector here to here, magnitude would be the length of this vector. So this would be magnitude. And direction would be the angle between this and the x-axis. So that would be theta. Now that we know what these two are, let's talk about how to convert them. Now, assuming we know I hat and j hat, so if we have a vector, we have 3i hat and 4j hat. Now, 3i and 4j hat would basically be if, let's erase all of this, and let's say each of these dots are a new coordinate or like one unit. 3i hat, 4j hat would be 3 to the right and then 4 up over here. So we would draw this vector and this would be represented as 3i hat, 4j hat. Now that we have 3i hat, 4j hat and we know what it means, let's figure out the magnitude and direction. Now, the magnitude is the x coordinate or like the x direction. So we just symbolize that by x squared plus y squared and the whole root of that. Now you might think it looks familiar, and if you paid attention you would know this is the Pythagorean theorem, because every vector you can draw pretty much a triangle from that vector over here, and the x and y are already given. You just have to find the c length or the hypotenuse. Now with this, the magnitude would be 5. Now you might be asking, what about for theta? Now there are actually two ways to calculate this. Actually 3 equations one can use to calculate this. If we know the magnitude, we can say that magnitude multiplied by cosine. We have x is equal to magnitude, so the a, and then multiplied by cosine theta. So theta is equal to cosine inverse of x divided by the magnitude. Now it would be the same thing for y, and these are actually also the formulas you can use if you have magnitude and direction and you need to convert x and y, so, or the I hat and j hat form. So theta, this is actually sine theta, not cosine theta. So theta is equal to sine inverse y divided by the magnitude of that vector. But what if you don't know what the magnitude of that vector is and you want to find direction as fast as you can? Another way is by theta is equal to tan inverse y over x. We can figure that out by using these two equations over here and having y over x. So y over x is equal to magnitude sine theta over magnitude multiplied by cosine theta. So we get y over x is equal to tangent of theta. So we get the formula listed above. Now, with this formula, what we would get is, if we plugged it in, we would get theta is equal to tan inverse of 4 by 3, which is equal to, if I'm not wrong, it should be 53 degrees. So that's pretty much it for actually solving for magnitude and direction and vice versa. But now, how do we combine these vectors together? But before we add, I think it would be more important to understand how we multiply scalars by a vector. So if we go to this end and we start doing that, let's say we have a multiplied, let's say 5 multiplied by a vector, let's say I had j hat. So 5 multiplied by the vector 3I hat plus 4j hat. This is actually the actual way of writing the vector. This is just expressing the coordinates of the vector. When we are adding or subtracting, we will always use the plus form. What we do is we would just use the distributive property. So 5 times 3I hat plus 5 times 4j hat is 15I hat plus 4j hat. 20j hat. So, in a nutshell, what we can do is we can say if we have C multiplied by a vector ki hat plus ki hat plus hj hat, this is equal to C multiplied by ki hat plus C multiplied by hj hat. Now that we know how to use scalars, we can now figure out how to add vectors. And adding vectors is actually very similar to adding numbers, especially when it's in the I hat j hat form. So if we have, again, our same initial vector, 3I hat plus 4j hat, plus then another vector, let's say 5I hat plus 6j hat, what we would do is we would group the I hats together. So I hat multiplied by 3 plus 5, then plus j hat multiplied by 4 plus 6. What someone can do is you just add up this. So we get 8I hat plus 10j hat. There you go, that's how you add it all up. But one final problem remains. How would we add it up if we're given the magnitude and the direction? Now there's no way to directly add it up. What we would have to do is we'd have to use the formulas I've given you to convert it into I hat and j hat, or x and y. Then we would add it all up together. Now keep in mind that subtraction is the exact same thing as addition, and dividing is the exact same thing as multiplying when it's by a scalar. Now those of you just here for review and already very experienced in math might ask me, well, when are you going to do scalar product or vector product? Now those will really come later when we talk more about work and energy. And vector product comes much later when we start talking about electricity and magnetism. So we have a long time before we cover that. And also scalar product is quite simple, but I'll cover it in another video since we will not need it for the time being, and I don't want to have to go through multiple examples to show you how scalar products work. The final step would, after converting these, would be to add it up. But then, oftentimes in problems, they will be asking you to convert right to back to magnitude and direction. Let's have an example doing just that. We have our problem right written down over here, and let's get to solving it. So, the problem states, add 3 times the vector with magnitude 7 and direction 60 degrees to negative 2 times the vector with magnitude 6 and direction 0. And let's add the final answer must be in the form where it states the magnitude and direction. So there we go. We'll have to do one final conversion step at the end, but it won't be too bad. Now that we have our problem finally written down, let's truly get to solving this. So if we have 3 times the vector with magnitude 7 and direction 60 degrees, the first thing is let's figure out that vector with magnitude 7 and direction 60 degrees. So our x coordinate would be x is equal to the magnitude, or 7, multiplied by the cosine of the angle, so cosine 60 degrees, and our y would be 7 times the sine of 60 degrees. Now our next angle, so if we call these x1 and x2, the next would be x1 and y1, it would be x2 is equal to 6 multiplied by cosine 0 degrees. Y2 is equal to 6 times the sine of 0 degrees. Now that we have this, we can solve for x1 and y1, and x1 is equal to 3.5 or 7 by 2. So let's just say 7 by 2. And then y1 is equal to sine of 60, which is the square root of 3 by 2. So 7 multiplied by the square root of 3 by 2. Then for our next one, 6 times the cosine of 0. So x2 would be equal to 6 and y2 would be equal to 0. But we can't just add these two directly. We have to multiply by the things I said earlier. So if we have the magnitude 3.5, 7.2, 7 by 2, and 7 times the square root of 3 by 2, and we multiply those by 3, then 3 times x1 would be 21 by 2, and then the next, so 21 by 2 I hat, then the next would be 21 times the square root of 3 divided by 2 j hat. That's just for our first thing we need to add. Then we add that to 6, so plus this, plus 6 multiplied by negative 2, so negative 12 I hat. And then since it's 0, we're still gonna have plus 0 j hat, so it's gonna be the same as it was earlier. So let's get to adding. 21 by 2 minus 12 is negative 3 by 2. So negative 3 by 2 I hat. This just stays the same, 21 square root of 3 by 2. So plus 21 multiplied by the square root of 3 divided by 2 j hat. Now it says we need to find out the magnitude and direction for this. So the magnitude would be x squared plus y squared is equal to x squared plus y squared, so x squared, so that'd be 9 by 4 plus 21 square root of 3 by 2, that would be 441 multiplied by the square root of 3 squared, so that would be 3, then divided by 4. Now we can factor out 1 by 4, so that becomes 1 by 2 on the outside, because after taking the square root you get 1 by 2. So then 9 plus 441 by 3. 441 multiplied by 3 would be 1323. So after that, if we add that up, we get 1331. So 1 by 2 multiplied by the square root of 1331. Now 1331 is 11 cubed, so we would have 11 multiplied by the square root of 11. So 11 divided by 2 multiplied by the square root of 11 would be our magnitude. The next thing we need to do though is evaluate the angle in which this would be from. So we have tan inverse of y over x. So 21 times the square root of 3 divided by 2 multiplied by the reciprocal of that, so negative 2 by 3. So here we go over here, then this becomes tan inverse of 21 times the square root of 3 divided by 3. What this would be, it would be some radian value above 45, and it would be a very long decimal that I really don't want to show right now. So I'll leave you at that. If you want, you can just plug it into Desmos or anything and figure out what it would be. The final thing I want to show you before leaving this video It's just a quick formula for evaluating if we have three components. So I had j hat and k hat. So what we would do is, if you wanted to calculate the magnitude of that, it would be the x component squared plus the y component squared plus the z component squared, square root, and this is just an extension of the Pythagorean theorem. But that's about it. And for the direction of these vectors, actually, there would be two angles, theta and phi, but I won't go into much detail for that in this video. If you want me to have a future video of vectors on this channel, or maybe on my math channel covering that, please make sure to leave a comment down below. And please make sure to like, subscribe, and hit that notification button if you found my videos fun or educational. So thank you so much, see you in the next one, and bye bye.